Hi, in this video I'm going to show you how to author simple collision geometry for static mesh assets in Unreal 4.26.1. It's important that you use 4.26.1 or later for this demo or this tutorial because there were some bugs in 4.26.0 that will prevent some of the tools I'm going to show you from working. But the result of this tutorial is you'll be able to do things like import a static mesh asset like these bunnies that don't have any collision geometry and author collision geometry using in-editor tools so that you can do things like do physics simulations of them like I'm playing right now. And they'll collide with each other and have reasonable collision shapes. And so let's start. Let's get rid of these bunnies now that I showed you that part. Okay, so just to try and, I'm going to spend a bit of a time explaining what that means in Unreal Engine, what collision geometry means. Because you might look at a bunny like this and think like that's the shape you want to simulate. But simulating this shape is very expensive. It has a lot of triangles, you can see. And in a physics simulator, all of those extra triangles add extra complexity. So generally, in Unreal Engine, you have to author collision geometry that's called simple collision. And it's going to be made of simpler shapes. The other alternative is called complex collision, and that is supported, but only for objects that don't move. This object right now has complex collision on it, actually. So I can show you. There's a show flag here. If you go to show and turn on collision, that's Alt-C hotkey, but only when you're in the viewport, you can hopefully see that now there's this kind of overlay triangle mesh, and that's the collision geometry. And you can see it's actually just the mesh triangles. And if we compare that, say, over here to this standard character, you see it has these simpler shapes. If I toggle it on and off, you'll see them, these kind of like tubes and boxes. And so for this character, that's the collision representation. I'll talk more about that in a little bit. But just to mention a bit about complex collision, particularly with respect to modeling tools. In modeling mode, which is what we're going to be using for most of this tutorial, when you create shapes, like when you create, say, a sphere box primitive here, say to use for editing, it also has complex collision. You can see it's got a lot of detail. So even though this could be represented by sphere simple collision, in modeling mode, when you make things, by default, we set them to complex collision. And the reason for that is so that you can do things like sculpt them. Because if I just grab this and want to do some Dynasculpting on it, now I can't represent this anymore easily with simple collision. I'll talk more about this as we go through. But since it's complex collision, I can still, pie in the viewport and hit those things. Run over to this sculpted thing I sculpted and jump on top of it. Well, I could if I was better at jumping. Whereas if we use simple collision, we would have to somehow automatically generate collision for this, and that's a very hard problem, so we don't have that. So just to make clear, the complex collision is the sort of default in modeling mode. But this tutorial is going to be about how do you make simple collision, because complex collision, as you might guess by the name, is expensive, and so you wouldn't want to use that complex collision in your game. In particular, it means you can't simulate things. So I can't simulate physics down here. I'll talk about this some more as we go on. I can't, simulate this falling like I can for stuff with simple collision because we don't support simulation on complex collision. Just to mention one more thing about viewing collision in the viewport is that there's also a tool, I might use this tool as I go along, but I'll just mention it up front, for viewing simple collision of specific objects. So I can always turn on Alt-C, but if you're in a complex scene, there might be too much. It might be hard to see, so you can select individual objects or sets of objects and use this PhysInspect tool, and it will show you the simple collision. So simple collision, here we go. We've got these two boxes. They look the same, but they actually have different simple collision geometry. So if I press play here, I want to switch this to, so if you want to see things running in the editor, you can run the simulate under play here. So I'm going to simulate that, and you see this box is floating. Why is it floating? Because its collision shape is a sphere and not a box. So even though the mesh shape is a box, the physics system doesn't see that. It only sees the sphere. And so I basically set it to a different kind of collision shape. And so that's why it behaves that way. And for more complex shapes, what we're going to try and do is approximate them with simple collision. Now, when I say simple collision, what do I mean? Well, there's certain simple collision shapes so that are supported. There's three basic shapes, which are spheres. These are called capsules, or sometimes they're called spheles, like sphere cylinders. And these are boxes. The sphere can be any radius, but it has to be a sphere. The capsule can be any length and radius, and the box can be any box dimensions, and it can be rotated. Any of them can be rotated. But those are the three shapes that we have, and I'll show that as we go along. And then there's also something called a convex. So what's a convex? I'm going to explain this a bit because I think it's not necessarily intuitive. So if I make a polygon right now, I extrude that. This is a complex or a convex polygon, or a convex shape. The 2D polygon was convex, and then I extruded it, and that made a 3D convex shape. Now if I go into poly edit and move this edge, it's convex, it's convex, it's convex, and now it's switched to being concave. So it's non-convex now. So what does that mean? It means that there's some part of the shape where it kind of has a cavity or indentation. And there's another way to explain this, which I'll do with a sphere. Oh, I made a sphere back here. I guess I kind of messed it up. Let's make a new one. Primitives. So another way to think about it, and this is useful to keep in mind as you're sort of trying to figure out how to approximate your shape with convexes, which is what a lot of this tutorial is going to be about, which is why I'm spending so much time explaining this, is if you take your sphere here and cut it with planes. So as long as we are just applying plane cuts to this sphere, it's always going to stay convex because the initial sphere was convex, and all the plane cuts never change, can't, as long as it's a whole plane, it can't change the convexity. The shape will stay convex. So I'm just going to do a few of them here so that I can more thoroughly explain. So you see we've got now these big planar pieces, and I'm kind of cutting away parts of the sphere. And actually, if you think about the sphere as mesh, each of the triangles was basically a little plane cut off of, say, like a box, actually off of the infinite space is how you should think of it. So I just made the sphere out of a bunch of plane cuts, and now I'm adding more planes. And this is actually how the collision system internally represents convexes, is as a set of planes. So only certain shapes can be made this way, right? In particular, if you think about this, I can never cut this sphere with a plane so that it makes an indentation, right, like that I did on this shape up here. You can see, right, if I grab this edge and move it in, those are all kind of things I can make by a plane cut, but once I put it in here, there's no way to cut this whole shape with a plane and make this V shape. It's just not possible mathematically. And so that's what we mean by convexes. And so if I have a complex shape like this, and I want to make simple collision for it, my options are to try and find a set of boxes, capsules, and spheres that kind of approximate it well enough that that it works for the physics system, or to construct convexes. Now, see, these are simple and they only get you so far unless you use a lot of them. Convexes, I can make kind of arbitrarily complex convexes, and we'll talk about that later. And so convexes can be more expensive, and so they're a middle ground kind of between complex collision and these simple shapes. And I mean, ideally you use the simple shapes, but sometimes you need convexes. And so we've got various tools in the editor already before modeling mode to fit convexes, and I'm just going to show you some of those so that we can do some comparisons. So if we open up the StaticMesh editor, there's always been this collision tab here where you can add different collision shapes. So if I wanted to make a sphere for this whole thing, I can turn on add sphere simplified collision, and that's going to make it fit a sphere, or I can remove that and add a box, right? Or I can add a capsule, right? Now these shapes are very coarse and they don't really fit, and you can actually select them and scale them and move them around. And this is a way, it's quite tedious, but to try and author simple collision, but you get the idea. I might basically come in here and try and get this to fit. Now I would have to bump the snapping settings around, right? And I could add multiple and try and fit them. That's pretty tedious, as you might imagine. So there's also some automated ones, like you can add something called a DOP. That stands for Discrete Oriented Polytope, I believe. And that's basically does what I was showing before with planes cutting a sphere, except it does it with a box. So I don't know why that's not working. Oh, anyway, but before I do that, I'm just going to turn off complex collision. So I was just going to mention that in the settings down here, there's a collision section, and this is where you tell something whether or not it's going to use complex collision, right, which can't be simulated, or simple collision. So there's this collision complexity, and right now it's set to use complex as simple. So that means it's going to use complex collision, and then you can also use project default is probably what you want, which was usually set to simple and complex, which means that it will use simple collision for physics and complex collision in the editor. You can also use your simple collision as complex, and that is has to do with raycasts, but let's just stick with project default, I guess, here. Let's try that one more time, adding the 26 DOP. There we go. So you see it's a set of planes. This is a convex, we call that a convex hull. It's a simplified convex hull. It's a bunch of planes, but it doesn't that closely approximate the shape. And if we were to simulate this, it would behave in kind of funny ways because it would always end up hitting these faces that are quite far from the model. There's one more method I'll just show, which is this auto convex collision. So that is actually down here on the bottom right, where you can set a number of hulls and a max vertex count and this precision. I'm just going to run it with the defaults. And you see what that did is it made some convex hulls that fit the shape, that kind of fit better. You know, it looks okay, but I'm going to show you actually that if we go out here now, if I turn back that collision view, that's the collision for the shape in here. And I'm going to compare it to the one that we had before. Ooh, what's going on? So I'm going to use this other tool in the volumes tab. That's where you put the collision tools, which is called MeshToCollision, or sorry, collision to mesh. So what that does is it actually takes those collision shapes and makes a mesh out of them. And we're going to use this for editing later. So there's the one from the auto convex collision, and here's the one that I hand authored before using our tools, collision to mesh. For some reason, and this is a bug in 4.26.1, the shapes that come out of this collision to mesh tool are inverted. So one thing you will have to do when you do collision to mesh is to go into the normals tool and do this invert normals operation. That actually doesn't matter for the physics system, but it does matter for our editing tools. So what you can see now that this bunny, I would say, is a kind of better approximation than this bunny. This one here has some parts that aren't very good fits. You know, the ears and head have been and some of the body have been merged in slightly odd ways. And so this is the advantage of doing it by hand. And you might have done this before in external DCCs because you can import collision by like authoring these shapes in another tool. But they're usually not designed specifically for authoring collision. And so the tools we have in the editor are essentially. And so what I'm going to do now is I'm going to show you the most basic way to use those tools. I'm just going to take this rock asset. I'm going to put it up here because I want to drop it later. So I'm going to use this tool, which you might have seen me click on accidentally already, which is called MeshToCollision. What this does basically is it tries to make collision geometry for your mesh asset. So MeshToCollision. Now there's lots of options over here I'm going to go through in this tutorial, but the basic thing is it's going to try and fit simple collision to this object, to this shape in different ways. And the simplest way is just to fit a single thing to the whole shape. So, you know, I can fit a box or a sphere or a capsule. These are all the simple collision shapes I told you about before. There's a few others I'll talk about, but the other one is convex hulls, like I said. So now it's fit a convex hull. I'm going to show you something. This is another sort of small bug, which is you can actually turn on hidden line drawing of these red lines, so you get a better sense of what the collision shape is. Unfortunately, as soon as we change a setting, that's going to disappear again. So you have to come and check and uncheck this, which is a little annoying. But the main thing to know is that there's this target face count by default. So when we're making hulls, this section will appear. And by default, we simplify the hulls. So if we don't simplify it, then it's based on the geometry. And so any like little tip, essentially this is doing that sphere cutting process automatically. It's finding all the planes it needs to, like as many planes as it can, cut the shape with geometrically. And so that's good, but this might be overkill for your collision representation. So normally by default, we have simplify hulls on, and you can kind of tune the number. It's very quick at small numbers for reasonable sized meshes. For really huge meshes, it can start to slow down. But let's say we're going to go with that. So I'm happy. I'm going to hit accept. So now this has that. If I turn on the collision view again, you can see, oh, this shape has, oh, sorry. I was using this tool before the tutorial, and I have this. So you can configure the collision type in here. I'm going to set it back to default as the output, which, or simple and complex is what it sets as the default. So now you see, if you can see in the video compression, that I've got my low poly shape there. I can use Phys Inspect tool to see it. And I can go down here and check Simulate Physics, and then just simulate an editor, and that's going to fall now and be a rock, you know, that I can interact with. And I think even, let's see, it might even be small enough that I can push it around. Yeah, I can kind of push it with my character. So that's very fast, right? Just to make your assets interactable and editable by physics. Okay, so the next tool in there, unfortunately when you do pi, it switches, I'm going to stop that, it switches modes out of modeling mode, is the, oh right, I'm going to go in here and use this chainsaw asset that I got off of Turbo Squid. So this is the asset. I'll put the link. So someone just, this is something I found. This is just a free asset made by someone named DJOL. But it was a good example of doing the collision authoring by component. So the simple way is to use the whole asset, right? And so if this was like a background object, maybe you don't care that much about super accurate collision and you just use a convex. Or you could even do something like, oh sorry, I guess convex is probably the only one that works here. You could do like a really coarse box maybe. But in addition to per input object, we also have Permesh Component. So what that does is it finds the disconnected pieces of this mesh. So if we, actually I can even show it, what I mean by component, we use this term quite a bit. If I go say in the select tool, I can color, no, that's not going to work. I don't have a good way to show that. But essentially that means is like it's disconnected pieces of the mesh. Oh yeah, actually I do. I can go select and I can go select all connected. So if I just paint here, it only selects the connected triangles. Right, and so you can see there's different kind of pieces to this mesh. And so the MeshToCollision tool, the Permesh component version, what it does is it fits a separate collision shape to each piece. So, you know, boxes or spheres, that's not very good, right? This front piece doesn't really make sense as a sphere. Or you can fit capsules. Capsules is actually not bad for this shape. It's a little bit funny on this piece. So that's one thing, is that because of how the pieces are set up, you might get some unusual shapes. And then Convex Hulls will do quite good fits, and you could tune the target count. You can't control the count per shape, and we don't have any kind of adaptive setting right now. A few other things I'll just show, so a few other options. So what, there's this max count here, so you can turn this up and down. Unfortunately, it only goes down to 4. There'll be a few examples later where you'd like it to go lower. But that essentially says I'm only going to use 4 capsules for this whole shape, and it takes the 4 largest ones. You can disable the max count, and then you'll get all of them. The other thing you do is this remove contained. So that's always checked by default, but if you turn it off, you'll get collision shapes for all these little pieces. So what the remove contained does, it's like if that piece is inside of a bigger shape, then you don't really need it because it's never going to get hit. at least with the sort of standard blocking collision. So we usually have that on by default. When we turn it off, you can see that there's a more effect of like the max count as it filters out small shapes. These detection settings won't do anything for this model. I'll show those later. What else is in here? Yeah, so the other modes that might matter specifically is the min volume node. So what this will do is it will try and fit a smallest, whichever simple collision shape. It doesn't use convexes, so only boxes, spheres, and capsules. It'll pick the smallest one for each component. Now this model, all the smallest ones are boxes, but I believe if we set this to oriented boxes, no, it still comes out the same. So that can be useful on some models like this where you have lots of small pieces and you just want to quickly make collision. I'm going to make this one capsules just to show it, and then the same kind of thing. Now it's an interactive thing, and sometimes like capsules are a bit coarse, but sometimes it can make sense, right? Now this thing will kind of float on the ground and definitely not fall through and stuff like that, which depending on your game, might matter. So there's one more option in there, which I'll use a different model to demonstrate, which is swept hulls. So we go back to modeling and go to volumes and do mesh to collision. I'm going to reset all these things to default. I'm going to keep it as components. I'm going to do swept hulls. So what swept hulls does is for each shape, it basically makes a 2D convex polygon of the shape. We talked about 3D convex hulls, and that's basically we took a plane and we cut it, or a sphere and we cut it with a bunch of planes. So a 2D convex hull, you take a 2D circle and you cut it with a bunch of lines. So maybe that'll be more obvious if I turn this setting up. So you can see for these pieces, I'm going to turn the floor off. Under the floor, basically we fit like a 2D polygon, and then we extruded that polygon to make the collision shape. When you're in swept hulls mode, you get the swept hulls section, and you can control whether or not you want to simplify the polygons. You probably usually do because they can be quite detailed for a high-res model. And then this tolerance here, rather than a specific number, this tolerance controls a kind of like error. You can basically set it by kind of tweaking it and eyeballing it, I think. And then there's different modes. So you can sweep along basically what it considers is it considers sweeping along the X axis. So you can see down in the bottom left, we got X, Y, Z. It considers those three axes in the local coordinate system of the shape. So there's sweeping along Y. So you can see we kind of fit, you have to find the right direction, but you can see like from this direction, it captured the curve here of that piece. And Z is straight down. And then you can set it to two things, which is smallest box dimension, which will fit kind of smallest shapes, the smallest widths. This shape, that doesn't really make sense. These bottom pieces get different ones. And then you can set it to smallest volume. So here it's going to fit basically vertical sweeps for all of them. And then I can play with this. Oh, we have tolerance setting. So it's, it captures some amount of this shape. If you wanted more detail here, you'd have to switch to convex hulls. And it's going to get more complicated. Now it captures more of the shape of these bottom pieces, but the table part is not as good. And dealing with that is something I'll show a little bit later about how to use different methods for different parts of a shape. But swept hulls is it's quite effective for lots of things like this in a game where maybe they're like pieces your character needs to be able to hit, but you don't need super precise collision on the whole shape. In fact, you might even be able to get away with, for like a table like this, just a single collision shape, like basically a cylinder, or maybe you'd even just use a capsule. The capsule fitting is kind of twisted here, so that can be one tricky thing you might when you do the auto fitting, is the things can be kind of skewed sometimes. But okay, so that's this table, and that's swept hulls. So there's a third mode in the MeshToCollision tool, and I'm going to use this. Turn the floor back on. I'm going to use this piece to demonstrate it. So this piece is it's like a doorway, right? It's a single connected set here. So the MeshToCollision tool it has a problem in that, you know, you could easily approximate this with 3 boxes, but you need some way to tell it that like the triangles in the middle here should get a separate box. So the way we do that is using the groups, using polygroups. So I have another video about polygroups, I'll link in the description, but essentially polygroups are a way to specify like decompositions of the mesh, and I'm going to use this select tool basically to make, oops, I got this set to all connected. I'm going to set that back to brush, and I'm just going to paint out this middle piece and create a polygroup for it. Now I can show the polygroups like I explained in that video using this other color mode. Now you see there's these kind of pieces. The mesh is still all connected. I didn't change the geometry at all. But now if I go back to MeshToCollision, leave it at boxes and set this to Permesh group, now I get a separate box for each of those pieces. And I can, you know, walk through it. Let's see. I actually don't know how big that thing is. Oh yeah, it's a reasonable size. I can go through the middle and I still hit the walls on either side. So I could have used complex collision for this. It's not super high res, but it's much cheaper to use 3 boxes. And if I was using this piece all over my game, it would be much better to use the 3 boxes than it would be to use complex collision. So that's how we do the groups, and actually that's how I did the bunny. So I'll just show you. Remember I had this bunny with the convexes on it, kind of hand authored. So if I go back to that select tool, you can see, I'll turn off wireframe, that what I did to make it is I basically painted, now these 2 colors are very similar. You can set the selection to by group. So you can see that there's different groups on these 2 pieces even though the color is very similar. And what I did basically is I painted out these regions so I can quickly use this, you know, other brush tools, and I'll do that in a few other examples to create a polygroup. So I just painted these out, and then when I go back to MeshToCollision tool, you know, it'll fit to each of those pieces. Oops, I picked oriented boxes. So one thing you should know is that the oriented boxes method is quite expensive. It's the most expensive one, even more expensive than convexes. And the reason for that is the way it works is first it fits a convex, and then it tests all the faces of the convex to find the smallest possible box for your shape. So it's mathematically the best box, but it's quite expensive to find them. As you see here, it did quite a nice job fitting boxes to the ears. You know, I could fit capsules. Capsules actually worked not bad for this bunny, but the other shape I had done was convexes, and I, you know, messed with the target counts and things like that to get a good approximation. Because one thing with convex is it still will miss areas if this count is too low. So here the back of the bunny is basically not going to exist to the physics system unless I use a higher count. You know, you can, if you uncheck simplify hulls, now you can see maybe what the real convex hull looks like, right? A lot of the triangles on the rounded areas will be in it. So this is what we're starting with, and then we're simplifying it down to a certain number of triangles to get smaller hulls. Okay, so that's how I did the bunny. Another thing you can do with this tool is you can use you can use other shapes to define the collision. So this can be really useful. So I'm going to basically make some spheres. I'm just going to set the pivot to the center. It makes it easier. I'm going to make these smaller. So right, if I want to make some spheres, maybe 10, that basically approximate this shape, you know, what I can do is just kind of click around on it. I'm just going to add some spheres. You know, I'm not trying very hard here to do a good job, and it's snapping to the grid. But now what I can do is I could select all those and select my statue last and do MeshToCollision, and it's going to take all those spheres and use them as the collision geometry, right? So now I could go in, you know, I might want to turn off grid snapping and reposition these, kind of eyeball it, make them fit better, make some bigger, and quickly jump over here and select, and then the last one, same kind of thing. And I can do this as a way to sort of set up my collision. Now when I'm done, I can go, you know, if I decided I want to use this many spheres, but I want to edit them later You can't do that using this tool anymore. But what you could do, if I deselect the statue, just get rid of these. So now my statue's got those as its simple collision, and I can go into the static mesh editor and turn on collision, simple collision, and then I can select those in here and move them around, right? Maybe I decide I want that one up a bit and I want to just get rid of this one. And so you can use the editing mode in the static mesh editor to do tweaks and things like that. Now, why would you want to approximate something with spheres? I mean, it's much cheaper, and maybe this is not that important of a shape. Maybe you only use a couple just so that it can bounce around a room if you hit it. So it's something to think about, is that you can use, depending on how important the shape is, you can use really coarse collision if you don't need to capture every piece of it. Another example of what you can do with that kind of editing, right? I'm going to bring in these stairs. So this is not that complex of a model, but there's actually quite a lot of triangles in these pieces. So if I do MeshToCollision on this, I'm not going to use groups. I'm going to do per component because they're separate, and I'm going to use boxes because really, ideally, I want to just approximate this with boxes. Now, I could, you know, the stairs have nice boxes. This other piece here, I could maybe make a hull that fits it, but what I'm going to do instead is just accept this, and then I'm going to go into here, to the static mesh editor, and select that one extra box, right? That's the box for the bottom piece, and delete it. And so now my collision, if I do the phys inspect, is just the 3 slabs, but because of the shape of this thing, that's actually enough. So the character, right, can't walk through it because they're going to hit that top one, and you can still walk up it. So that's often kind of stuff you can get away with if you kind of edit the collision. So if you had lots of stairs, it might be a significant savings to just have collision for the stair steps and not worry about the rest of the shape. If you did want to worry about the rest of the shape for other reasons, like maybe you need, you know, bullet decals to hit it or something like that. So I'll just show you another thing you can do with other editing tools. So I said before you could author, like I did with those spheres, other pieces. So I'm going to go into create and do the polygon tool. So I'm going to hit control. My drawing plane is over here. I want it here. I'm going to hit control. I'm going to control click on this, and that's going to align the plane with it. And now I'm going to turn off snap to, let's see, I want to snap to, yeah, okay, angles, lengths. So the snapping I've demoed before, it will actually snap to the vertices of these stairs. So what I can do is just kind of rely on that. I'm going to look for those vertices. There's one. Oh, that's what I'm going to disable the snap to angles because it's interfering. It's the circle. When you see the circle, that means you've snapped to that shape. That vertex is kind of hidden. I'll just use this one. So, and then I can maybe do this one, this one, this one. Now it's closed, and then I'm going to just eyeball this to be ballpark the right distance. So now I have this other shape, right, which is maybe a ramp, essentially treating the stairs as a ramp. So now if I select also the stairs, control click or shift click, and I do MeshToCollision, now it looks weird because what it's doing right now is it's fitting a box to those other stairs, and it's doing it in the local coordinate system of those. So when you want to use other shapes like this, you generally have to use world space. So if I click use world space now, it uses the world space location of the other thing. So it's still fitting a box. So I don't want that. I probably want a swept hull, right? Because that was basically an extruded polygon. So a swept hull is always going to be the shape. Now, a swept hull and a convex in the collision system are the same. So I could use either in this example. They're the same. It's just toggling some edges. It looks like the swept hull has slightly fewer triangles, and that's better generally. And so I'd use the swept hull. I could also keep the stair step. So if I check this append to existing, it'll also keep the stairs that were there before. So I could have made this shape maybe tighter, or I also could have potentially authored 3 extruded boxes if I wanted the stairs to be really accurate. I guess if you wanted bullet decals, that's probably what you would do. But essentially, right, the stairs are non-convex, and so we need to break them up into convex pieces. And so Extruded boxes might actually be the way to go there. But that's how you use kind of authored meshes to make the collision. Now, just a reminder that this does make assets. So this extruded stairs here is this asset here, and I don't really need that asset. So I can delete it. I could delete it right now. It's going to give me this issue about force deleting, and it's going to clear the undo stack. So what I usually wait is until I'm done, and I either delete them or I close the level and don't save those assets. Just a little reminder about asset management. Okay, I'll show you some other kind of more advanced techniques for using the authoring tools, the other authoring tools to make collisions. So here I've got this shader ball. I'm going to do mesh to collision. I'm going to change this to spheres because these are basically, it's a big sphere. I'm going to set this down to the smallest. Now here, I probably only want two spheres basically. What I'm going to do for this one is the bottom is pretty well approximated by a sphere, and maybe that's enough for my context. So what I really want is a sphere to fit the top piece and a sphere for the bottom. But here you can actually see there's multiple spheres because the top pieces are separate components. But if I set it to per input object, I just get one sphere for the whole thing. So I don't actually like either of these. So what I'm going to do is I'm going to make, based on this model, I'm going to make another shape that will be good for collision. And then I'm going to use that. So what I'm going to do first is I'm going to go to the Create tab and do this vox wrap operation, which is a little expensive. I'm going to turn this down to 64 just so it's faster. But what this does is it basically kind of voxelizes the whole thing. I'm going to set down here, instead of deleting sources, I want to keep them. And I'm just going to accept that. So that's going to make a new asset. Right, there's the asset. And that's this, it's very dark in this lighting, but it's essentially the voxelized version of this. I guess we could set this to my white material so that it's clear to see. Okay, so now it's still just one shape, so it's not there yet, but what now I can do is go use the plane cut tool, and it has this option to keep both halves. So now I can kind of cut up this solid into pieces. So I get that plane at the right height, and you can increase this spacing. In this context, it won't matter. You can see I'm basically just inserting a gap. And I'm going to uncheck export separated pieces. What that would do is that would make a new asset for this base piece, and I just want to keep it all together as a single asset with multiple pieces. I click accept. So now I've got my sort of solidified shader ball. So now if I select that and then shift select the original and do mesh to collision and do Permesh Component, now you see it fits one sphere to the top chunk and one sphere to the bottom chunk. And so that's a way you can use the tools to make simpler pieces that you can then kind of do to set up the collision quickly. In fact, this is kind of an interesting way to make complex collision geometry for things, and that's something I'll talk about in a future tutorial. Okay, so I've got one more shape here that I'm going to do, which is this chair. This chair is quite complex for collision, depending on what you're trying to achieve. I mean, maybe you just want a box, but if you wanted to actually capture, say, like the separate base of the chair, right? If you think about it in terms of volumes, there's a lot of non-convex areas, so it can be tricky to set up collision for something like this. So what I'm going to do first, because basically this won't do anything good. There's only one. The other thing that's tricky about this mesh is that it's all merged together. So like, if I go into Selection Tool and select All Connected, what you see is that the whole thing is connected. So these pieces have been Boolean together, these like separate base and back, or even maybe hand authored as one single piece. And so a lot of our tricks that we use so far won't really work. So what I'm going to do is I'm going to make a duplicate of this chair, and I'm going to edit that chair in pretty coarse ways, but that's going to be sufficient for collision. So first thing I'm going to do is go to the Transform tab and duplicate it. I'm going to keep the source. I'm going to make a copy. So now I've got a separate chair. So the reason I duplicated it, this is not the same as alt dragging it. So alt dragging makes a new component and actor with the same asset. When I use this duplicate tool, it makes a new asset. So you see I've got two chairs down here, and that's because I want to mess around with this one. It's going to be kind of throwaway, and I'm going to use that one to make the collision for the other one. So I'm going to jump into the Select tool, I'm going to set this to by material, or no, sorry, by UV island. So the reason for that is just to make selecting quicker. So you see I can change these color modes, right? None is the original color. But if I go to UV island, what I see, and this is pretty common, that your mesh is going to be, with materials already, split up into kind of pieces that can be good in this context. So basically, what I'm going to do is create polygroups for some of these pieces, but because there's no groups. If I switch this to by group, you see there's no polygroups right now. So I'm going to make polygroups based on my painted selections. So I'm going to make a polygroup for this base piece. So I click create polygroup. Now it's just going to disappear, but if we switch back to by group, you see I made a polygroup for it. So I'm just using the UV islands to make my selection faster, basically. So I'm going to select these two. And then, so right now the hotkey in 4.26.1 is Control to multi-select. I think we're going to change that in future. Now I've got these two. I'm going to go back to brush mode because I just want to add some, and this is when I said before it's going to be kind of coarse. I just want to add some stuff up here so that the convex hull fitting captures the whole top of this thing. I actually don't really care that much about how far down it goes, just as long as we kind of get the boundaries. Okay, so I'm going to create a polygroup for that much. And then, so now if I switch back to groups, I've got the bottom and I've got a group for the back, and now I need to get the arms. So actually I can just leave it in by group. But now I'm going to make the brush really small, and I'm just going to paint along the arms here. I actually only really need like a kind of surface. Let's turn the floor off. I really just need kind of a surface slice of each side. So that's a, rough boundary and stuff, but it's going to work for what I'm going to do next, which is fit some shapes to this kind of strips. So I'm going to create one for that. Okay, now I'm going to switch this to by group. I'm going to select these three groups I made, and then I'm going to invert the selection and delete it all. So now I basically got this mesh that has 4 pieces for what I want the main collision pieces to be. So then I'm going to shift select this one and go mesh to collision. I'm going to set this to oriented boxes, works pretty well here. I'm going to disable this append to existing. That's actually, I think, from a previous attempt at this. So now you see I got collision shapes for these 2 arms, and one for the base here and one for the back, and they're all kind of like just automatically quite good. I've got the kind of angle on the arms. So it did take me 2 tries or so before I did the video to figure out the right way to break it up to do this, but I think it was probably faster than if I tried to carefully make pieces that fit this. So I'm just going to accept that. Right now I press play. Now this is a functional chair where I can get on, I can stand on it, right? If I had a sitting animation I could set off, I could sit down in that chair. It's pretty good for 4 boxes. Now, one small thing, right? The collision on it, if we use Phys Inspect, you see it's kind of coarse up here. So I'm just going to show you one more workflow that can be quite useful with that collision to mesh tool. So these 3 boxes I think are fine, but I might want to use a convex for this piece back here. So one way to do that would be to do collision to mesh tool. That's going to make a new version of it, right? These are actually assets too, so you can see here's the asset for this piece. Now what I'm just going to quickly do is jump into the select tool and set this to all connected. I want to get rid of these 3 pieces. I'm going to delete those. I just want to edit this back piece. And over here, I'm going to go into the StaticMesh editor just now and get this done, because I want to get rid of that one here. So I'm going to select it, and I'm going to delete it. So now it's gone, and we're going to basically make a new collision piece from this. Oh, I disabled. Oh, that's right. So one thing here I mentioned before about using other shapes, about it being in world, if they have the same pivot in local space, then you don't need that. So I'll show you. So what I'm going to do is quickly, let's put it over top. Ballpark, put it over top. I moved it with snapping disabled, which means like it's hard to get it back in the exact same spot. I could go here copy these numbers, type it in the numbers for this one, but I'm just going to eyeball it for now. So I'm going to just quick poly edit this. Let's turn off faces and vertices, get that edge, move it over until it's closer on the top. Maybe here. Now I've got that piece. I'm going to shift select my chair. I'm going to go back to MeshToCollision. I'm going to check append to existing, right? Because right now it's going to delete those other pieces. I don't want that. So I want to keep those pieces. And I want to fit a convex hull to that back, right? Because that one I want to be a convex. So this is a way you can kind of accumulate collision from multiple objects. You can also keep, if I had made other objects with other collision geometry, so if I had duplicated this twice and done convex hulls on the one part, I can use keep existing. So you can kind of append from multiple objects. It's not the greatest workflow right now, and we're going to improve that in the future, but it does work. Okay, so now I can get rid of this piece, and I've got my chair with its more complex collision on the back. Okay, and I'm going to do one more example, which is this tank model, which is another model I got off of TurboSquid. I'll paste the link in the description. So this is a much more complex, right? It's quite a large. Let's turn the floor back on. Model. I put it up here, hit end to drop it down to the ground. Right. So this tank actually has 500,000 triangles. It's got tons of pieces. A lot of things are going to. Actually, I should have probably disabled. So right now it's fitting convex hulls to all sorts of pieces, which can be kind of expensive. Oh, I guess only 4. So technically it only fit 4 pieces. Now one thing that's weird is you see this sphere in here. That's because of this auto detect setting. So I didn't talk about these before, but what these will do is if it can find something that it thinks is a sphere or a box or a capsule in the geometry, in the triangles, it will use that instead. That's how before when I used the sphere meshes, they were turned into spheres automatically. I forgot to mention. So I'm going to uncheck those because they're actually kind of expensive to compute for each piece. And on this model, we're not going to use any of them. We don't want those. Okay, so I want to make collision for this tank. I just want to quickly make some coarse collision. But I'm going to say I want to capture some of the features. So I've got this max count set to 4. But in fact, none of the automatic methods work well for all the pieces. So I'm going to change this to swept hulls. And so here we go. Oh, right. I want to uncheck append to existing also. I've already done this once, and so that's why it has some existing collision on this asset. So you see here, like on the top, what I would like to do is capture just these 2 cutoffs. Now I could do that, I showed you before, by like making the thing and editing it. What I'm going to do is just use Z, and that's going to capture that piece. Now that works great for that piece, doesn't really work for this side piece. So what I'm going to do though is I'm going to say, okay, we'll take that. And then I'm going to do collision to mesh. Drag that over here. You see it flip the normals. We'll go back. We'll fix the normals. And then I'm going to jump in the select tool and I'm going to say both of these are bad. Delete them. And there's a piece, random piece back here, which was the next biggest piece because we have that minimum of 4. So that one's okay. Now I'm going to run the tool again. So because the mesh is so huge, this takes a few seconds each time. And now I'm going to sweep along a different axis, which is Y. Y is sort of sideways. And that's going to give me the sort of main body here. So I'm going to accept that. And do the same thing, collision to mesh. Drag that over. Invert the normals, just so for editing. get rid of these, and this other random piece. Right, so now I've got these two pieces that basically cover the main body. They actually have all of the same pivot, so I can just now, I mean, if I only cared about those two main pieces, right, if I didn't want that, then I can just select those two and this one, and do mesh to collision, and it's going to use those pieces, uncheck world space because their pivots are all the same, and then if I made the things with swept hulls, I can use convex hulls to reproduce them. We don't automatically detect convexes, but if you use convex hulls on convex hulls, you're going to get convex hulls out. So now I've got those two main body pieces. And I'll just show again, right, we could use the method I showed before to capture the treads. So I'm going to, you know, I want to draw a polygon basically. So I'm going to Control-Shift-Click somewhere close, and then I'm going to hold Shift to rotate 90 degrees because I'm not sure any of these faces is exactly perpendicular, and I think this will just be easy. It's kind of dark here, but now if I just look from the side, one thing you notice is I've got my field of view here set quite low. This makes it easier to do this kind of thing. I'm going to disable all the snapping and just kind of eyeball it. Oh, that's weird. Doesn't snap closed. And then drag it over. I can actually use the other side. If I move my cursor away from the extrude, it's going to snap to that size. It's a little wide here, so I'll just jump into poly edit. Oh, I got faces unchecked. Move that over until it seems like about the right spot, maybe there. Okay, and now, so this is also an extruded piece, so that's also a convex. Now the only thing is, now I need to move these back because this one on the bottom has a different pivot than these two. So I gotta drag these over and align them. And I'll shift click my other piece there, and then finally shift click the tank, and do mesh to collision. Now I use convexes, and it's going to fit a convex hull to each of those pieces. And so now I've got my final tank. I guess I didn't do the barrel, but I think you can figure out how to do that based on the other stuff I showed you. Now I can turn on simulate physics on this, and maybe here, and we'll just simulate an editor. Right, and now it's a functional sort of tank piece. It will, right, because I didn't do the barrel will go through the ground. But like I said before, you could fix that. I remember, and then these pieces have complex collision on them because we made them with the modeling tools. Okay, so that's the end of this tutorial. Quite long, but I wanted to show you all these different kind of ways you can leverage the different modeling tools to make collision for different shapes. So I really only use the extrude, right? But we have lots of primitives. The revolve tool, if you draw a convex curve, you can revolve to make circular pieces. Polypath is very easy to make non-convex shapes, so that one's probably not the most useful. You can do things like using the booleans and stuff like that to kind of quickly make approximate geometry that then you can use the fitting tools to fit convexes and other shapes to try and assemble sort of simple collision directly in the editor. Okay, so that's the end of the video. If you have questions or comments, please don't hesitate to post in the YouTube comments, or I'll post my Twitter handle there. And I hope this video is useful. Thanks for watching.